For the second day of Chapter 12, we'll be in Notes, page 4 and 5. This is working with analyzing arithmetic sequences. When we look here, we're going to show whether the sequence, which is this list of numbers, is arithmetic. As we talked about yesterday, to test for this, an arithmetic sequence, we're going to take a term and we're going to subtract the one before it, and we expect to get a common difference. So let's take a look at what we have. If this is considered our A1, this is our A2, and so forth, we're going to take a term minus the one before it. So negative 3 plus 5 gives you 2. Then we're going to take a term minus the one before it. Negative 1 plus 3 is 2. Take your term minus the one before it. Take a term minus the one before it. So we notice that each difference is 2. It's called a common difference. So yes, this is arithmetic, which we would call it arithmetic sequence. We're going to show that this is arithmetic. Well, you're going to take your term, subtract the one before it, get negative 5, take the next term, get negative 6, that's concerning. Take the next term, we get something different. Okay, so now we can say that this is not arithmetic because it does not have a common difference whenever you subtract a term by the one before it. When we write a rule for any arithmetic sequence, we can use this pattern right here, where we put our first term, the number of terms, minus 1 times d, which is your common difference. I often like to write it as a of n equals a of 1 plus d n minus 1. Doesn't matter which side you put the d on, you're going to distribute it through. I like to put it on that side. Remember that an explicit rule, that's what this is. This is an explicit rule. You should be able to plug in the position that you want to get your answer. Where the recursive rule, you had to start from scratch and work your way all the way up. An explicit rule, you should be able to plug in the 10th term, a 10, to get to 10th term, a 28 to get to 28th term. So we're going to write a rule, it's called an explicit rule, for this sequence of numbers. So first of all, we notice that 9 minus 2 equals 7, and 16 minus 9 equals 7. So we're testing to be sure that it is arithmetic. So we know our first term is a 2. We know our common difference now is 7. So we're going to use our rule here and plug in our values. So to find a term, we're going to take the number 2, our common difference of 7, times n minus 1. We can clean this up. So we'd have 7n minus 5. that would be considered your rule for this sequence. So if you wanted to know the second rule, the second term, you should be able to plug in a 2. 14 minus 5 is 9. If you wanted to know the fourth term, you plug in a 4. 28 minus 5 is 23. We're going to take a term minus the one before it. So we get a common difference. So we know our first term is, of course, 57. Our common difference is negative 12. So we're going to start with our formula. We're going to plug in the values that we know. Our first term is 57. Our common difference, here we can say minus 12 and minus 1. We're going to distribute that through. And we're simplifying the way that this looks. We're going to start with a negative 12n and positive 69. So if you plugged in a 4, you get negative 48 plus 69 should give you 21. It's a good way to test it. Be sure that it works. Write a rule for the nth term, and then we're going to find a term. Well, we're going to find the 22nd term here. I guess alright. I guess up here we were going to find the 19th term. To find the 19th term, you typically plug in a 19. So it's a of 19 equals 7 times 19 minus 5. So we're going to get 133 minus 5. So the 19th term should have equaled 128. And on this side, to figure out the 19th term, a of 19, we take negative 12 times 19 and add 69 to it. So that's going to come out to be negative 159.